Good work, students. Now the next question will be we are doing through assumed mean method. So in assumed mean method, what we have to do and what formula we are going to apply here. The formula will definitely be x bar is equal to assumed mean method. We always apply this formula f into dx by n. Okay. In case of mean deviation, this will be dx dash. So that is a different scenario. We'll look into it. But as of now, a plus summation of f dx by n. So this will be the formula which we will be using. Now what do we calculate? The first thing which we will calculate is mid value, which is x. Okay. So see how to calculate mid value. As we know, this is assumed mean method. So what do we do in this assumed mean method? You'll have to assume a mean, okay? And you cannot select it from frequency. So what we need to do? First of all, mid value. So what we do? Add the lower limit and upper limit and divide it by 2. That means 0 plus 4 and make it half. So this will be 2. This will be 12. Half will be 6. This will be 20. Half will be 10. This will be like 28. The half will be 14. So what I'm doing? I'm doing this L1 plus L2 divided by 2. Lower limit plus upper limit divided by 2. Okay. I'm adding these two values. Lower limit, upper limit divided by 2. I'm adding these two, lower limit and upper limit. Okay. In the previous question, already I wrote the formula over there. Now we'll be assuming. So let us assume something. Let us assume like rounded value 10. Okay. Now dx will be x minus a. Okay. After this, which column will be there? F into dx. This f into dx, summation of f dx. We want this column actually. For that, we'll have to calculate x minus a. So let us calculate 2 minus 10 will be minus a. 6 minus 10, this will be minus 4. This will be 0, 10 minus 10, and this will be 4. So what this value will be? See, two values are in, or deviation you can say, they are in minus because these are smaller values than 10 and this one is higher. So now what we are supposed to do? This is f into dx now. So f is what? F is this value, number of students. Because this is class interval, this is marks, okay? So this is not a frequency definitely. This is just class interval. So this is a frequency. So in frequency, we are going to multiply these two values. Okay, like 4 8s are 32, but sign will be of minus. Okay, then again 4 8s are, so it will be 32, sign will be in minus. This will be 0. Then the last one will be 4. Okay, now let's do the total for this. So what is the total? This will be minus 64 and this will be positive value. What will happen? Minus 60 will come. We will write minus 60. Okay. Now, what do we need? This value we are having. Assuming we know it is 10. What you are not having? N. What is n? The total of this thing. So it will be 4 plus 8, 12. 12 into 14 and this will be 15. So 15 will be the total. It is n. Okay. So we will put this value here. So let us put what is a here. It is 10 plus summation of f dx. This value is in minus 60 divided by 15. Okay, now just cancel it out. 15 ones are 15 and 15 fours are 60. So we can say that 10 minus 4 is nothing, it is going to be 6. So this 6 will be your x bar, or you can say it is going to be your mean. So we have solved this question by assumed mean method. So this is the way. How do we do it? Calculate the mid value from this lower limit and upper limit. After that, dx we need to calculate. Assumed mean, always select a or assumed mean from this x value. Don't take from frequency. Take it from x value. Here I took it from this one. Now this was a. Okay, 10. And then what you have to do? You have to take deviation of this assumed mean. Okay, so how much is the deviation? Like this is x value and the deviation we are checking here and writing this deviation over here. Then the multiplication of all those deviation by frequency f into dx. F into dx and deviation से अपन multiply करेंगे. Okay, then sum it up. Minus minus वाले पहले जोड़ लिए फिर plus वाला and this will be the answer. Okay, so just note it down. Thank you. Now our new numerical will be solving this by step deviation method. Okay, so in the step deviation method, now as we know, see here the problem in this, the lower limit, okay, it is ending with 29 and this upper limit is starting with 30. So actually this series is called as inclusive series. So basically we used to convert it into exclusive series, but in case of mean it is not required. So you can just solve it directly. The concepts remain the same. Concept वही रहेगा जो हमने बाकी के सवालों में किया था, न्यूमेरिकल्स में किया था. Here again you will have to calculate step deviation by mid value, which is x. So first of all we are going to calculate this mid value only. So it is going to be 49, so 49, so lower limit plus upper limit divided by 2, so this is going to be 24.5. Now this is going to be 69, so half of 69 will be 34.5. Okay, L1 plus L2 divided by 2, I am doing this. Now I know that this is a difference of 10, so I can write this 44.5, 54.5 and 64.5. Okay, this is how I have written everything. Now what we are supposed to do after this, we know this is frequency. Now straight away we can do fx if you want in case of direct method if you want to apply. But here the case we are solving this by step deviation method. So what are we supposed to do here? Step deviation means what? We'll have to calculate dx first. So definitely you'll have to assume something as a. Your assumed mean should be there. So what you want to assume here? I would suggest that we can use this 44.5. Okay. Now x minus a. This is what we are supposed to do, x minus a. Okay. Now what is x over here? These are the x values. So the difference we have to write. So x minus a. So definitely this is something in the minus. So it will be 20. Then this is the difference of 10. Then 0. Then this is positive value over here. Okay. Now the next step will be just like we are doing earlier. जैसे पहले मेथड में हमने किया था. अब हमको क्या निकालना है? dx dash. So we will be doing dx by c. इन वैल्यूज को अपन कॉमन फैक्टर से डिवाइड करेंगे. You can see कौन सा कॉमन फैक्टर है. It is 10. Just like in any other numerical. So here we will be dividing it by 10. So it will be minus 2, minus 1, 0, 1 and 2. Okay. So let us make some space for this fdx column also. Now fdx dash, you know the last column will be fdx dash column will be there, of course. So for that I need to make some space. Yes, f into dx dash, these are the value. Dx dash, where is the f? This. So first one will be minus 20. Okay, 10 into minus 2, then 8, it will be minus 8. Then 6 and 0, 0. 1 and 4, 4 it will be. 2 and 2, 4. We are multiplying f into dx dash. And the total of this we want over here. Okay. So let us calculate this total. So of course this total is going to be minus 20. Okay. How? Positive 8 minus 8 cancel out. Minus 20 will be there. Okay. Now what will be the formula? Okay. The same formula as we were doing earlier. Like summation of f into dx dash divided by n into common factor. Common factor we have taken as 10. I have not written here. Here the common factor c would have been 10. Okay, because you are dividing it by 10 only. 10 was the common factor here in this dx values deviations. Now what was here a? Assume 44.5. Write it 44.5 plus summation of f dx. How much it was? Minus 20. Then what is n? So n, we have not calculated the n. Let us calculate. So this will be 28, 30. Okay. So 30, let us write it. Okay. Into c. What is c? C was 10. 0, 0. Now 3 6 are 18. Okay. 3 6 are 18. Then 20 remaining. 18 to 20 again. 3 6 are 18. So 6.6 something. So we can do it like 44.5 minus 6.6 it will be. Okay. So this is going to be the answer. This is going to be your 13 minus 6, it will be 7, and this is going to be your 3. 37.9. So this is going to be your answer. 37.9. Your mean by assumed mean, sorry, by step deviation method. Only one step increases, one or two step increase over here. Dx dash will be there. Okay, in case of step deviation. So how many method we have learned in this individual method, discrete method, and this continuous series method, there were three: direct method, assumed mean or shortcut method, or this is the last one, step deviation method. Okay, so just note it down.